Hi guys, and welcome to today's lesson on displaying and describing numerical data, part of our general maths series. It's really good to see you. Thanks very much for stopping by. Now, if this is new to you, then hi, I'm Darren, MaffsGuru, and this is my little corner of the internet where hopefully I'm going to make maths interesting, entertaining, and bloody easy for you to be able to follow along too. So if you haven't already done so, if you can subscribe to my YouTube channel, it's going to just tell me that there are people out there watching. Yes, I know I'm that sad and lonely and desperate that I really would just like you to tell me that you're watching. Leave a comment if you're on YouTube. MaffsGuru.com is my website where I've got the videos organized by textbook, downloadable notes, time codes, exam questions, and so much more. So again, head over there, it's absolutely free. What are we going to do? Today's learning objective, or at least for this particular video, understand the tools we can use to display numerical data. In previous videos, we've looked at categorical data and bar charts. Now we're going to do numerical data, understand what discrete data is, know how to group data, understand what a histogram is used for. What do you mean you already know this? Ha! Yeah, maybe you do. And know how to construct a histogram using the CAS. Ka-ching! Okay, so if you've looked at my previous videos, you know that we've looked at the types of data, we've looked at bar charts and frequency charts, and we've looked at how to write reports to describe these things. Again, if you haven't seen the videos, hey, stop this one, go and watch the rest on MaffsGuru or on YouTube. It'll actually be the foundation. Why is this important to you? Well, further maths, units 3 and 4, believe it or not. Those of you who are here in Australia, further maths units 3 and 4 is basically statistics crazy, chapters 1 to 6, and a huge sack on all this type of stuff. And I still can't get my head around the fact that we call something a sack. Whole new discussion. Did no one think of this? One of my previous schools, interestingly, also had a building called the CAC. Okay, all right, so what is discrete data again? Discrete data takes whole number values, okay? So discrete data are things like numbers of brothers, numbers of sisters, number of cars, number of people, because you're not going to have decimal points in these. Well, then you turn around and you go, well, hold on a moment. In the last video, you said that shoe sizes were discrete. And yes, they are, because you don't really measure a shoe size, or more importantly, you can't have a decimal point that goes more and more and more into sort of the long number. So what I'm basically saying is you can't walk in an order of 7.321 shoe. Likewise, you can't walk in an order of 7.536 shoe. 7.5 is there simply because for some reason we decided to put a half size in. Interestingly, places like America don't have half sizes, and so much respect to the Americans for working out to use discrete data. Yeah, probably not why they did it, but it sort of works for me. Okay, so again, discrete data can't be measured, yes, in a sense of with a tape measure or a timer or a stopwatch or something along those lines. So we're now going to look at constructing a frequency table of this information, yes? In the previous video, strangely, we just already had it there. In this video, which feels like we're doing it slightly backwards, we're now going to construct a frequency table. The numbers of brothers and sisters reported by each of the 30 students in year 11 are as follows. Now, with any luck, there are 30 data items there, and the numbers are going to go between, well, first things first, to construct a frequency table, we need to know the numbers we're dealing with. So first thing we're going to do here is called siblings. All right, so I'm going to have a table and I'm going to have a title with siblings. And we know probably the lowest number is going to be 0. It's highly unlikely you're going to have negative numbers of brothers and sisters. I don't even know how that's going to look. And then you have, what's the highest number? 4 or 6? Flipping heck, 6. 1, 2, 3, 4. 5 and 6, right? So our table is then going to go up to 6. Now we're going to have some sort of tally, believe it or not. Now, why am I going to do a tally? It's just going to make my life a little bit easier. And I don't think this is in the Cambridge Essentials, the Cambridge textbook. Now, again, thank you very much to Cambridge for allowing me to use your resources. They are phenomenal, and I'm deeply, deeply grateful. Your textbook's second to none. So what I'm going to do through now is, and there's two ways of doing this. Lots of people will look through and go, I'll look for all the zeros first. Yeah, to be honest with you, you're going to make mistakes, all right? Maybe not so much or so important for a tally chart, but this is what I do. I go 2, I put a cross through it, I put a tally at 3, put a cross through it, put a tally at 3. 4, put a cross through it, tally at 4. 0, put a cross through it, 0. 3, put a tally at 3. Now, obviously, we could continue doing this and you will be bored senseless. So don't fast forward. I'm actually going to stop here. But obviously, once you've finished your tally, you would then write the total number of tallies for each of these rows in this section here. And that would be your frequency. And at the end, you would have your total, which would hopefully add to 30. One of the things I do is check for 30. Now again, as I say here, when you construct a frequency table, find the lowest number and the highest number, and then fill the numbers in between. Do a tally chart, makes life easier, but make sure you use a system. So obviously I was doing number, 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 and the chances are I'm not going to miss one. You notice I've always put lines through them. Again, it's just a check. And ladies and gentlemen, there we go. That is our frequency table. Now again, if we build on the knowledge that we had the last time, what did we have? Well, we had two columns. We had one for the number, which was the raw number, and there was one that we worked out as a percentage. Now, just to check, how did we get this percentage of 20%? Well, you took the number frequency, which was 6, you divided it by the total number, which is 30, and then you times it by 100%, which in this situation would have given you 20. Now, again, the table has been done to one decimal place, just to make life a little bit easier for us. And again, those of you who watched my previous video would be like, hallelujah, that adds up to 100 and all is good with the world. No fudging needed. Yes, I said fudging. All right, so there we go. We got our frequency table with both the number and the percentage, but what do we do with it now? So in a previous video, we had categorical data. Yes, so there would be categories, which meant we would have drawn a bar chart. But the thing is, well, what do we do with this data? Well, again, just slow down for one moment, because strangely or sadly with numerical data, sometimes we get really massive data gaps, right? So our lowest value could be 1 and our largest value could be 1,000. And obviously in that situation, we are not going to have 1,000 rows. So what can we do to try and help us with that type of data? Well, believe it or not, we can group the data. Whoa! Now, in this situation, basically, we then split the data into what we call an interval. And so our intervals may be, for example, 0 to 9, 10 to 19, 20 to 29, and so it goes on. So what I'm now going to do is, if I was to draw my tally chart, if I got the number 5, I'd put a tally in here. If I got the number 7, I'd put a tally in here. If I got the number 23, I'd put a tally in here. All right, and now what that means is if we had the numbers between, say, 0 and 100, because they're effectively going up in tens, then what I would end up with is about 10 intervals, yes, or 0 to 99. Now, something else you've got to make very, very sure of here is that you don't have any overlapping numbers. And sadly, a lot of people make really strange mistakes by going, well, I'll have 0 to 10 and 10 to 20 and 20 to 30. And that's all well and good if you have the number 5, because I know that that's going to fit in there. But the question is, what if somebody gave you a response of 10? Now in this situation, what you've noticed is you've got 10 in 2 different intervals. And for maths, that really doesn't work very well. Yes, we can solve that problem a little later on, and I'll come back to that maybe in a later video. But at this moment in time, we try not to have any confusion. So for discrete data, we would go from 0 to 9, 10 to 19, making sure our interval was the same distance, yeah? So as I say here, it's important to note that every data value should be an interval. The interval should not overlap, and there should not be any gaps between the intervals, right? So I know you're going to say, yeah, but hold on a moment, there's a gap between the 9 and the 10. But there isn't, because if I'm counting people, I'm not going to have 9.3 people, yeah? So let's have a look at another example now. With this situation, we notice that our data is much, much wider. If we look at our lowest number here, it is 0. What is our highest number? It seems to be 34. Now in this situation, we're not going to end up with 34 rows in our table. That would be ridiculous. So we're going to have them in an interval. We're going to group them. And the question suggests, or this particular thing suggests, that what we're going to do is we're going to group the interval 0 to 4, 5 to 9, 10 to 14, 15 to 19, 20 to 24, and so it goes on. And again, do you notice there are no overlaps? I've got no repeating numbers, and there is no gaps between any of my numbers that I could miss some. All right, so what I would do now is I go, well, okay, 2 will go in here, do a tally. 0 goes in here, do a tally. 9 goes in, oh my goodness, there, do a tally. 10 goes in here, do a tally. 23 goes in here, do a tally. And again, I would wait until my table was finished. I'd end up with my number frequency, my percentage frequency, and ka-ching, there it is for you. So again, this table has already been pre-populated. You notice that we were dealing here with cups of coffee. How do you know that? Because it was in the, it said a group of 20 people. Now again, 20 people we'd have to make sure that our number column added up to 20. If it didn't, you've made a mistake. You've missed something off, which if you've got a system, the chances are you're not going to miss anything off, right? So just have a system. Drank in a particular week. And again, what do we notice? We got 8 cups of coffee, or 8 people drank between 0 and 4 cups of coffee a week. My type of people. How do we get this 40%? Well, I took the number of people, which was 8, divided by the number of people who are asked. So 8 people drank between 0 and 4, 20 people in total. And when I put that into my calculator and times by 100, ka-ching, out came 40%. And again, those values add up to 100. These are all things to check that you don't make a mistake. If they all add up perfectly to 100% and the total number of people, you're good. You'll be fine. Trust me. Now we have another example, all right? So I know there's a lot of examples here, but it's important to understand how to do the histograms that are coming up, yeah? Because if you get your data in the right intervals, life is good. And again, there are now 41 players in the basketball club. Oh my goodness, they got decimal values. It's all too complicated. No, it really isn't too complicated, I promise you. And again, the questions are giving you an indication of the interval sizes. So 170 to 174.9. Now again, in this situation, because we're dealing with discrete data, that 0.9 is just something for us to use. There's not going to be a 0.91, there's not going to be a 0.92, so we're fine. The next one's going to be 175 to 179.9, 180 to 184.9. And again, this works beautifully. What would I do then? I'd go do my 178, it would go in there, 0.1, 184.6 would go in here, and again, continue working your way. Now in this situation, for some reason, I decided to work down my columns. Doesn't really matter. I could have worked across. It is personal preference. But by putting those little marks through it, means you're not going to double count a number. Well, hopefully not. And lo and behold, here we go again, a completed table. Yes, here are my heights. Let's just check how many people were in the survey. 41, yep. Do I get 41 players? I do indeed. Now again, look at that. That's going to mess with my head, something chronic. 101%. You can't have 101%. So as I said in the previous video, fudge it. Yes, that's basically me just saying, just change one of the values. And again, probably something that's not going to make a huge difference. To be honest with you, I'd probably do it 31.6, just to make it all nice and easy and to stop messing with my head. Again, we can work out the percentages by taking the original value. So in that situation, 4 divided by 41 times 100 will in fact give me 9.8%, rounded to 1 decimal place. How do you know which number of decimal places to round to? The exam or the question will probably tell you. Ka-ching, life is good. RTFQ, read the flipping question, and you can replace the F with anything you like. The mode, or is it? When we look at the previous table, we can see that while we have the frequency and percentage frequency, we no longer have the actual data. So I'm going to go back, and this is the problem with grouping data. If we look here, we now know from that table, if we didn't know that this data was here, all I know is that between 170 and 174.9, there are 4 data items, but I don't actually know what they are. All right, and you're not going to be able to find out. So you need to take that into account a bit later on, yes? But what we do know is the interval in which the mode appears. And so, bearing in mind from the last video, if we were doing a bar chart, for example, we would know that the modal category would be this one here, because it's the one with the highest bar. Now we're going to be looking at the modal interval. So again, if we go back to our previous example, what we would know is our highest number was 13, and so our modal interval would be 180 to 184.9. Now, when is a bar chart not a bar chart? When it's a histogram. Yes, ladies and gentlemen, on the whole, a bar chart and a histogram are exactly the same thing, except histograms don't have gaps, and histograms deal with numerical data. So if you have numerical data, you're always going to draw a histogram. And as it says here, there are certain things that are important. You know, frequency is shown on the vertical axis, the value of the variable are plotted on the horizontal axis, columns, very similar to a bar chart. So let's actually have a look. Here is a histogram from discrete data. So what we now have is we have 6 siblings and we have one. So I'm going to say, remember, if you remember, that along the bottom is going to be my siblings. In this situation, it's my siblings because frequency always goes up the side. What is the lowest frequency? It appears to be 1. The highest frequency is 7, so it's perfectly acceptable to start from a frequency of 0. So I now know that that's going to go from 0 all the way up to 7. What about my siblings? Well, my siblings are going from 0 to 6. All right, so in this situation, I'm going to go from 0 to 6. So what I'm going to do now is very badly draw 1, 2, 3, 4, 5, 6. Actually, that's not bad. That's pretty good. I'm going to extend it 1 square out because I always do it 1 square out, and I'm going to write siblings. And then I'm going to go, how many did I go? 7. So I want to go 8 up. 1, 2, 3, 4. 1, 2, 3, 4. 5, 6, 7, 8. I am not even sure that's going to be 8. So I'm going to do 0, 1, 2, 3, 4, 5, 6, 7, and 8. Remember to label your axes because otherwise you're going to lose marks. And again, now, for the siblings, when you have just single digit values, you actually write the value in the center of the bar. So I'm going to have 0, 1, 2, 3, 4, 5, and 6. And what we can see there is, you notice, they are in the center of each of those tick marks because that's where I'm going to draw my bar. So what do we have? 0 siblings was 6, so I draw a bar like this. Again, you're going to do this much. Actually, do not do the whole artistic coloring and thing. 1 sibling would be 7, so I would draw a bar for 7. 2 would be 6 again, so 2 would be 6. 3 would be 5, ka-ching. 4 would be 3, ka-ching. 5 would be 2, and 6 would be 1. And ladies and gentlemen, there is my histogram bar chart with no gaps. Yes? Ka-ching, thank you very much. Easy peasy lemon squeezy. Now, when we move on to interval data, things slightly change. Whereas in this situation, if you remember, there I did the values between the bars because we had individual discrete data in between the bars. Here we have intervals. And so much like we do normally with a graph, we actually count up in order. But we're not interested in these end intervals here. We are only interested in, well, I'll leave that one, the start intervals. So you'll notice my first value is 170, 175, 180, 185, and we keep going up in 5s until we get to 205. My frequency is still on the vertical. What was my lowest frequency? It was 1. My highest frequency is 13, and for whatever reason, the textbook decided to go up in 5s. That may well be due to space. You may decide to go up in 1s, but after a while you go up too high and it all just gets a bit silly. So how did they then draw it? Well, we said that the first interval, which was 170 to 174.9, but we're going to count it as 175, had 4 people in it, and there we go, we drew a bar with 4 people in it. The next one, between 175 and 180, had 5 people in it. And so we've gone along bit by bit by bit. Now this takes practice, yes? Individual numbers, remember, between the bars, intervals, either side of the bars, but you must count up in order, yes? Don't forget your units and your axes labels, and you will be awesome. Now, how to use the calc to draw a histogram? Basically, long story short, I've changed schools and so now I'm using a TI Inspire. Sorry about that for Casio ClassPad, but I will add instructions for those in a later video. But long story short, what I've managed to do is I've put my data into my calculator and I've basically gone to a graph. So I've inserted, or Control I, inserted a graph, and lo and behold, up came my information. Now, when I clicked on this section here, it gave me the opportunity to choose marks. And when I selected marks, then I ended up with a dot plot. Now, we're going to come up to dot plots in another video, probably one after this one. But here, what did I then do? Well, I said, well, okay, I don't want a dot plot, I want a histogram. So when you actually do menu, you get plot type. And then, interestingly, you then hit 1 and you end up with histogram. And you sort of turn around to your histogram and you say, well, okay, let me draw a histogram. Yes. Now, again, once you've done that, it goes and draws a histogram for you. Life is good. I'm trying to rush on, but it won't necessarily have given you the right widths of the bar or the right intervals. And again, what do? You turn around and you go, okay, and I've seemingly lost about 147 steps, but in this situation, what do? Well, number one, you go to plot properties, menu item 2. Then it seems that you go to histogram properties. Makes sense. Then you go to bin settings. I don't know why, but for some reason the width of a histogram is called a bin. I put rubbish in it, whole new discussion. Then you go and say something like equal bin width. You want your bin width, you want your intervals to be equal. Makes sense. Now in this situation here, you'll get 2 options. You get what we call width and alignment. Now width obviously is fairly self-explanatory. If I want them to be 4 wide, I make them 4. The alignment is basically saying, where do you want the graph to start? What's the first number you want it to start at? And in this situation, we said 2, yeah? And lo and behold, up comes my graph with my histogram with bin widths of 4. Life is good, the world goes crazy, and what you notice is that we have the number frequency up the side. But what if I wanted percentages? Well, guess what? You can do percentages as well. Again, you go back into plot properties and then histogram properties, and then you go histogram scale. Percentage, and lo and behold, out comes this wonderful graph here with your percentages, yeah? Now again, takes practice. Put these instructions into your summary book and jobs are good, and it'll look amazing and you'll never get this stuff wrong. Obviously the longest part here is putting the data into your calculator. And ladies and gentlemen, there we go. I am at the end of this video. I know it's felt really, really long, but histograms are quite important. They come up much later on, but I'm going to call it a day for this one. The next few videos I know are much shorter. Hopefully you'll stay with me if you're still watching. If you found this useful, can you leave a message below if you're on YouTube, or send me an email? Greatly appreciated. Head over to YouTube and subscribe, just shows me you're watching, or MaffsGuru.com to get access to all of the stuff that's over there as well. But otherwise, I'm going to call it a day. Thanks very much for watching. I look forward to seeing you in the next video. Take care. Bye-bye. Stay safe.